Exponents, man. Final video for this week. Let's get it. Alright, yo. This warm-up served a specific purpose. Is because I wanted to blow your minds mathematically. Alright. So here we know we need to do PEMDAS, right? So you need to do exponents before you multiply or divide, right? And so 2 to the second power is just 2 times 2. So this is -1 times 4, right? Because 2 to the second power is 4. -1 times 4 is just -4, correct? And that's important because now we get to -2, right? This negative sign and this 2 to the second power, but there's no parentheses here. And so another way to write this negative sign would be like -1 times 2 to the second power, right? And so this is actually just -2 to the second power 2 times 2, which is -4. Like, that blows my mind because you take out the negative or you ignore this negative sign and you do 2 to the second power, which is 4, and you get -4. It's crazy. If we think about it like this way first, it makes sense because the parentheses show us that you do the exponent first and then -1. Where here, right, it's -1 times 3 to the second power, it's 9. And so this would just be -9. Now we have -3 to the second power. Do you see the difference here now? How this is in parentheses? This means -3 times -3. So this would be -3 times -3. A negative times a negative is a positive. So this is 9. And so this would be +9. Why? Because this negative number is being raised to the second power. It's a negative times a negative. This says something completely different than this. Another way to look at this other than -3 times -3 could be, right, our -1 to the second power times our 3 to the second power. -1 times -1 is 1 times 3 is 9, which is 9. And so our negative cancels out and we're left with a positive. So let's get into our instruction. All right, let's go with example 1. Consider the statement. A negative number raised to any whole number power will be negative. Is this statement always, sometimes, or never true? And so here, consider the statement. A negative number raised to any whole number power will be negative. So argument 1, let's do -2 to, let's say, the second power. And so this would be -2 times -2. And so a negative times a negative is a positive. And so this would leave us with 4. And so we just got a positive number. All right, well, let's try argument 2. So what number comes after 2? Well, 3, correct? And so let's try -2 to the third power. And so this would be -2 times -2 times -2. Remember, your power just tells you how many times your number or term is multiplying itself by. And so we already did this. Negative times a negative is a positive, so this would be +4. Bring down our -2. 4 times -2 is -8. And so here we got a number that was positive. And then when we raise it to the third power, we end up getting a number that was negative. So right off the bat, this statement, a number raised to any whole number power will be negative, is not always true because argument 1 proved it wrong, but argument 2 proved it right. So that means this statement is actually sometimes true. So the statement is sometimes true because what's the difference between 2 and 3? What kind of number is 2? What kind of number is 3? And so raising it to the second power, 2 is an even number, 3 is odd. And so this statement is sometimes true because if you raise a negative term to an odd power, your answer will be negative. But if you raise your term by a even exponent, I should say negative term by an even exponent, your answer will be positive. And so if you raise it by an even power, your answer is positive. If you raise it by an odd power, your answer will be negative. That's because each time it's going to reverse this sign. Let's go to example 2. All right, let's do example 2. So, consider this statement. An odd number raised to an odd power will be odd. Is this statement always, sometimes, or never true? Justify your response. So, let's choose an odd number. Let's do 3, but we also need to raise it to an odd power. So let's do 3 to the third power. And then for our second argument, we can still do 3, but why not raise it to the fifth power to see if it stays true? And so 3 to the third power is just 3 times itself, 3 times. And so 3 times 3 is 9, times 3, we end up getting 27. And so right off the bat, we can see 3 to the third power gives us an odd number. What about 3 to the fifth power? Well, that's just 3 times itself, 5 times. 1, 2, 3, 4, 5. Let's do it again. 3 times 3 is 9. We can do 3 times 3 again to get 9. Carry down our 3. 9 times 9 is 81. Times 3. Bring it down. Now, maybe you know this, maybe you need to do it on the side. 81 times 3. 3 times 1 is 3. 3 times 8 is 24. And so this just ends up equaling 243. We can see this number ends in the number 3. That means this number is odd too. So both our arguments, when we raised an odd number to an odd power, we got an answer that was odd. So according to our test, this was always true. Something really cool, if your number is odd and you raise it to any power, you would actually still get an odd number. For instance, 3 to the second power is equal to 9, while we just did it. 3 to the fourth power was equal to 81. And so when you get an odd number, no matter what power you raise it to, it's always going to be an odd number. So the statement is always true because when you multiply an odd number by an odd number, your product will always be odd. As a result, raising an odd number to an odd power. Let me make sure you guys can see this. Always results in an odd answer. And so I encourage you guys to put this in your own words, because what we remember from MCAS is you need to make sure that you guys explain your work. You won't get full credit if it asks you to justify your response and you just write, it's always odd. How do you know that it's always odd? Make sure you guys explain. Thank you guys. Alright, here's the stopping block. Feel free to pause the video and copy this down, so this way we can move on to our challenge problem.